All right, so we're starting today one of the most important parts of first year chemistry, and that's knowing how to write formulas and how to name them. Um, so let's get right to it here. First off, we got to talk about the different type of compounds. Ionic compounds are composed of elements that are donating and accepting of electrons. They give electrons or they receive electrons. They typically are solids at room temperature. Um, they have very, very high melting points and very high boiling points. For example, um, sodium chloride is an ionic compound, and sodium chloride, there's the formula. Sodium chloride certainly has an extremely high melting point. It takes a lot of energy to melt salt, as opposed to something like sugar, which is an ionic. Sugar is covalent, has a much lower melting point. Um, and the reason that it is such a high melting point is because there's a lot of attraction between the sodium ion and the chloride ion that make up the compound. They can be binary or ternary. Binary means two elements. Elements. And ternary is three or more. So very important to distinguish between binary and ternary. So what exactly is an ion? Well, it's a charged particle. That means it can have a positive or negative charge. It can be a monatomic, in other words, made up of one single element. Or it can be made up of two or more, which we call polyatomic. So polyatomic ions are charged particles with two or more elements, and monatomic ions are charged particles with only single elements. Um, you can get the charge from looking at the valence. For example, sodium has a valence of 1, and we've already talked about this when we talked about electron configurations, but if sodium loses an electron, that means it has one extra proton. So if you have 11 positives and you have 10 negatives, what's your net charge going to be? Well, it's going to be a +1 charge. But oxygen has a valence of 6, and we know it likes to gain 2 electrons. So if you had an oxygen atom gaining 2 electrons, and its proton value stayed the same, well, what's 8 positives added to 10 negatives? Well, the overall charge is a -2 charge. So you can get the ionic charge from knowing the valence of the element. There are names for the ions. If it's positively charged, it's called a cation. And if it's negatively charged, it's called an anion. Cation has a T in it, looks like a plus sign. I've also seen teachers use this. Is supposed to be a cat ion. See, it looks like a cat, and it's got plus charges for eyes. And this is an ant ion. Get it? You see the negative sign going. It looks more like a ladybug, but there are different ways to remember it. But positive means cation, negative means anion. The cations are typically going to be metal because they tend to lose electrons. And when you're identifying an ionic compound, typically you look for a metal at the beginning. So it starts with a metal. Usually it's going to be ionic. Metals don't often form covalent bonds, which is sharing of electrons. So let's look at some examples here. We have the phosphate ion. It has a negative charge, and it's made up of 2 or more elements. So we say it's a polyatomic because it's 2 or more elements, and it's negatively charged, so it's an anion. Polyatomic anion. Potassium has a +1 charge. You'll notice the positive is missing. Excuse me, the 1 is missing. We usually don't write the 1s. You can if you want, but usually just write the plus sign, or negative, as we'll see later. and it's composed of just one element, so that makes it monatomic, and it's positively charged, so that's a monatomic cation. Magnesium, one element only, so monatomic, positively charged, so that makes it a monatomic cation, just like the K+. Ammonium, NH4 with a plus charge. We notice it has two elements here, so that makes it polyatomic. And it's got a plus charge, so that makes it a polyatomic cation. Oxygen, by itself, makes it a monatomic, and it has a -2 charge. We know that it's negatively charged. That means it's a anion, so it's a monatomic anion. Phosphorus, by itself, so it's monatomic, -3 charge, so it's negatively charged. So that makes it a monatomic anion. And then last, nitrate, NO3, we see it has two or more, in this case just two elements, so it's polyatomic. And we see it has a negative sign, so that makes it an anion. And it also, you'll notice that there's no 1 after the negative sign. Again, the 1 is optional. So that makes this a polyatomic anion. All right, so that's part 1 of our formulas and nomenclature PowerPoint.